what we're going to focus on is how we can find trig ratios of certain common angles. And by common angles, I mean angles like 30 degrees, 45 degrees, 60 degrees, 90 degrees. Those are what we would consider common ones. Ones like 23 degrees, that's not very common, okay? But I mean, you look around, just as an example for construction and design, you look around anywhere, you look up here, you can see 45, 30, and 60 degree angles, okay, as well as 90-degree angles. So we want to be able to find trig ratios of these angles exactly. And by exactly, I mean without the use of a calculator. Because whenever we punch a trig ratio into a calculator, we always get an approximation, not an exact value, okay? We are going to work on exact values now. And then we're going to use those to evaluate trig expressions, and we're going to use those to solve certain types of trig equations. So the first thing we need to do, okay, is we need to set up what is called a unit circle. And unit means one, okay? So a unit circle, and I'm just going to skip ahead a little bit here. We use a coordinate grid. And we draw a circle around the coordinate grid, around the center, where the radius is 1. That's 1 unit, okay? And the center is at 0, 0. So we have a point on the unit circle, x, y, and we can make a triangle out of it, but this is 1. This is whatever the x coordinate is, the horizontal length. This is whatever the y coordinate is, okay? And there are certain coordinates that are on the unit circle, and there are certain coordinates that are not on the unit circle, okay? We want to find ones that are. Like, for example, you don't have to write this down, but if I said the point 3, 4, okay? So that means that's 3 and that's 4. Does 3 squared plus 4 squared equal 1 squared? No. So 3, 4 is not on the unit circle. We can't put it on here. It's way out here somewhere, okay? We only want to focus on ones that are on the unit circle. So we want triangles, because we're doing trig, where the hypotenuse is going to be 1. And where we're going to use common angles like 30, 45, 60 degrees. So what we need to do is we need to create some right triangles that have common angle measures, 30, 45, 60, okay? And we need to make one so that the hypotenuse is 1. So we can fit it into the unit circle. So here's an example of a triangle where we've got a right triangle. Each of these angles measures 45 degrees, which means not only is it a right triangle, it's also isosceles, right? Because the two angles are the same, these two sides are the same. They have to be. So we're going to say, okay, this is 1, this is 1. So by Pythagoras, we could find the hypotenuse. And remember, when we're dealing with trig on a coordinate grid, we don't use A, B, and C, we use X, Y, and R. So x squared plus y squared is equal to the hypotenuse squared. Well, 1 squared and 1 squared is 2. So 2 is equal to r squared.
So to find R, remember we're solving a quadratic equation, so you got to remember to take
the positive and negative square root.
Oh, sorry. We should put 2. I don't know why I'm putting on a square. But every hypotenuse is positive, so we cancel out the negative. So that means
That the length
this length
is the square root of 2.
if I say this side is 1 and this side's 1.
Okay?
But I don't want root 2. I want 1 here. So I can put it into the unit circle.
On a coordinate grid.
So what I have to do is I have to create a proportional triangle. So we've got a triangle right now that's 1, 1, root 2, and the two acute angles are 45 degrees and 45 degrees. I need to make that into a triangle, a smaller triangle, where this isn't the square root of 2, which is 1 point something, it's 1. Well, don't write this down, but if I said this, if I gave you this, 3, 4, 5, and I said, here's a proportionally bigger triangle,
6, 8. What's the hypotenuse? What's this length?
if I want to go from this to this.
What's happening to each of the sides? Sorry? I can't hear you. Yeah, they're getting doubled, aren't they?
So doesn't that mean this gets doubled? So it's 10, right? If I said this, give you a triangle where this is 5, 12, or no, sorry, I'm going to give you 10, 24. And I want to make a smaller triangle where this is 5, this is 12. Sorry, this is 25. No, it's not. It's 26. And I want to take this and proportionally shrink it to this.
What's the hypotenuse? How'd you get that? You divide by 2, right?
Get the idea? So, how would we go from root 2
To 1. What would we divide by?
root 2? And to make it proportionally smaller, I have to divide these by root 2, don't I? These things would stop. That'd be crazy. So that means I have to divide this by root 2, and I have to divide this by root 2. So I get 1 over root 2 and 1 over root 2.
But remember, we didn't want a radical in the denominator, did we?
What do I have to multiply to get rid of this radical?
What do I have to multiply root 2 by so that the answer is not a radical?
Root 2. And whatever you do to the bottom, you have to do to the top. So 1 times square root 2 is root 2. Square root 2 times square root 2 is root 4, which is 2.
So we get root 2 over 2.
Obviously, this has to be the same, root 2 over 2. So if I want a hypotenuse of 1 in a right triangle where these are 45 degrees, I'll write that again. Keep in mind, this is 45 degrees. These two sides,
Have to be root 2 over 2. They have to be. Okay?
so what we can do now is we can put a right triangle where the acute angles are 45 degrees into the unit circle. Remember, the hypotenuse is 1, because that's the definition of a unit circle. And what were these legs that we found? Root 2 over 2. And root 2 over 2. Which means this point here on the unit circle is root 2 over 2, comma, root 2 over 2.
So whenever you have a 45-degree angle on the unit circle,
And you make a right triangle out of it, the point you're going to get is
root 2 over 2, comma, root 2 over 2. Okay? Now, let's do the other two common angles that we're going to work with.
30 degrees and 60 degrees.
How do we do that? Well,
We are going to take an equilateral triangle. Remember, equilateral triangle has all sides the same, and it also has all angles the same. Well, all the angles are the same, they have to be 60 degrees.
right?
So that means that this is 2 and this is 2.
But I don't want the entire triangle.
I only want half of it. Why? Because the angles in half of it are 30 and 60, which I want to find. So I'm only going to take half the right triangle, like so, where this is 60 degrees, this is 30 degrees. We've made this side 2. What would this side be?
What would it be?
1, half. Has to be half of this.
And since I know 2 of the 3 sides, I can find the third side by Pythagoras.
So to find the third side, this one, which we'll call y, because it's vertical, it would be 1 squared plus y squared is equal to 2 squared. Well, 1 squared is 1. Plus y squared, 2 squared is 4, so y squared is equal to 3. Therefore, y is equal to the plus minus square root of 3. But we're dealing with positives right now, so we cross out the negative. So that means that this side
Is the square root of 3. We don't use a calculator because we want exact angles.
But I don't want a hypotenuse of 2. I want a hypotenuse where I'll make it small. I want a hypotenuse where this is 1. What must I divide every side by. Divide by 2. Which means I gotta divide this by 2. And I gotta divide this by 2. So what is the square root of 3 divided 2? Well, it's the square root of 3 over 2.
Again, we're not using calculators here.
What is 1 divided 2? 1 half. So when we have what we call this a 30, 60, 90 triangle, because those are the three angles. So when we have a 30, 60, 90
Right triangle.
and the hypotenuse is 1, this long side must be root 3 over 2, and this short side must be 1/2.
Okay. Now we're going to take this and put it into the unit circle.
And we're going to do it 2 different ways. We're going to orient it so that the 30-degree angle is coming out from the center. Or we can change its orientation so the 60-degree angle is coming out. So this would obviously be 30 degrees here, and this would obviously be 60 degrees here. Well, remember, we just created right triangles where the
Hypotenuse was 1.
what was the length of the long side? Not 1 over 2, root 3 over 2. The shorter side is 1 over 2. Why?
Because this is bigger than this. The square root of 3 is 1 point something, right? Where this is just 1. So this is bigger. So that always root 3 over 2 represents the long side
In a 30, 60, 90 triangle. So therefore, this one would be the short side of 1/2. This would be the longer side of root 3 over 2. So these points, well, the x is root 3 over 2. The y is 1/2. When a 30-degree angle is coming out. When a 60-degree angle is coming out, it's reversed. It's 1/2 comma root 3 over 2.
Okay, so we basically took those triangles from the first 2 pages and put them in here.
So to summarize, here's what we've done so far. We found points on the unit circle when we have triangles
Where the angle coming out from the center is 30 degrees, 45, and 60.
What was the coordinate when it was 45? Root 2 over 2, comma root 2 over 2. What was it when it was 30? 3 over 2, comma 1 over 2. And then when it was 60, it was the reverse of 30.
So you are now familiar with 3 angles and their corresponding points on the unit circle. 30, 45, and 60. While there are other angles.
For example, what if we had, I know this is a little hard to wrap your head around, but what if we had a right triangle where the angle coming out was 0 degrees. Wouldn't it just be like that? Right? What's this point? 1 comma 1 comma 0. So when we have 0 degrees or just a flat right triangle, the point on the unit circle hits at 1, 0. What about if we went up to 90? What's the point on the unit circle? 0, 1. So therefore, at 90 degrees, the point on the unit circle is 0, 1. So now you know 5 angles. But we can do multiples of these angles. Okay, and this is where the unit circle comes in. Now, I should have taken, I keep remembering to take this out, but we're not going to be doing the next 2 pages where it says the families. We're going to go straight to the big circle at the end, near the. We're going to go to this. This is like an important page in a math Bible. This is something you want to keep. Okay? So, and I'm going to use different colors to represent different families. Let's start with 45 degrees, and I'm going to use purple. 45 degrees comes out in the middle of quadrant 1. What was that point on the unit circle again? 2 over 2 comma root 2 over 2. Okay. Now, a family member of 45 degrees in the second quadrant goes out in the middle. What angle is that? How would you find it?
360 minus 45.
360? All the way around minus 45? If we did 360 minus 45, I'm down here. Yeah, it'd be 180 minus 45, which is?
135.
Wouldn't it be the same coordinates? Except what? The x is negative. The y is still positive. So the numbers aren't different, it's just the signs are different in one. Let's go to the family member in quadrant 3, which would be 180, that's 45. So 180 plus 45. What? 225. What's the point on the unit circle?
Both negative.
Well, negative, but still root 2 over 2's. And then finally, the family member in quadrant 3. What would that one be? Angle measure.
360.
360 minus 45, which gives us 315 degrees. What's the point on the unit circle?
Root 2 over 2 minus.
Root 2 over 2, and then negative root 2 over 2. So that's the family of 45 degrees. 45, 135, 225, 315. And they all have root 2 over 2's in them.
It's just that one or more are positive or negative.
Let's look at the 30-degree family. What was the point on the unit circle? Remember, it's long, short. Root 2 over 2, 1 over 2. The family member in quadrant 2 is here.
Yeah, but what's the angle?
180 minus 13.
180 minus 30, which is?
150. And yes, you are right. It will be negative root 3 over 2. And 1/2 is still positive. The family member in quadrant 3
Is the angle
180 and another 30, 210. Again, we have root 3 over 2 and 1 over 2, but this time they're both negative.
because we're in quadrant 3.
And then finally, the family member
In quadrant 4,
360 minus 30 gives us 330. And again, we'd use root 3 over 2 and 1 over 2, but this time the 1 over 2 would be negative.
two more families to look at.
The 60-degree family.
Well, we got 60 degrees.
And the points on the unit circle would be? And root 3 over 2.
The reverse of 30.
The family member in quadrant 2 would measure 240, that's quadrant 3. Yeah, because it'd be 180 minus 60, which gives us 120. And here, the first number, 1/2, would be negative. The second number, root 3 over 2, stays positive. The family member in quadrant 3 would be 180 plus 60, 240. Again, it would be 1/2 and root 3 over 2, but this time, because we're in quadrant 3, they're both negative. And finally, the family member would be 300, because it'd be 360 minus 60. And what would the coordinate be?
1/2 and then negative 4.
This is what these guys are doing right now too. Doing the same thing.
Finally, the family of 90. Well, we start here where we get 0 degrees. What was the point on the unit circle at 0 degrees? 1, 0. Then we go straight up to 90. And the point on the unit circle? Then we go straight to the left on the x-axis, and that measures 180. And that point on the unit circle is? Then we go straight down, 270. And that point would be 0, -1.
And notice there's another angle measure here.
Because not only is this 0, it's also 360.
And that is the unit circle.
So basically, you have to remember these and these
In quadrant 1, and then you can figure out the other ones in quadrants 2, 3, and 4.
and there's patterns here that you can look at. Like notice,
First of all the denominators are 2.
with the exception of the 90-degree ones.
Okay? They all have a denominator of 2.
Notice the numerators in the x's go √3, √2, and then √1, which is 1. And this goes √1, which is 1, √2, √3.
Follows a pattern. I don't suggest any way to remember it because all of you will figure out a way to remember it on your own. I mean, I think there's a song out there you can sing, which I certainly am not going to do. Okay, I think we know that. I think there might be even poems out there or something that you can use. Okay,
To me, I just remember all the denominators are 2, and then I remember I go 3, 2, 1, 1, 2, 3. And like I said, if you know these ones, it's easy to figure out these ones.
okay. So, that being said, without looking at this, can you answer any questions? I'll give you a second to just sort of take a look at the unit circle. I know it's the first time you've constructed it, so it's going to take some time, but you'll get it. Everybody gets it. So just to show you what I think when I see something like this, there's 2 ways you could ask. I could say, at a 45-degree angle on the unit circle, what's the point it hits? That's what we're asked to find here. Or I could ask it the other way around. A point on the unit circle is this. What's the corresponding angle?
So for me, when I see 45 degrees in my head, I'm thinking, oh yeah, the 45 degrees
Goes in the middle. And that's the one where the 2 numbers are the same. And what are those 2 numbers that are the same?
√2/2, comma √2/2. Again, 180. I'm thinking, okay, 180 goes there. So what's that point? At 180. Well, isn't this a length of 1, but because it's to the left, it's negative? So what would this coordinate be? -1, comma 0. Get a little bit more challenging. 150. 150 is the one that comes down here. That's the 30-degree family. Remember the coordinate? Yes, but because I'm going to the left. And then what's the other number?
I can't hear.
1 over 2.
Thank you. 1/2. 240. Let's do that one. 240. That's the family of 60 degrees because it goes like this.
-1 over 2.
And then,
And then plus negative root over 2.
right. This one's a little easier. This one goes straight up.
0, 1.
This one, 315, that's quadrant 4. That's the one that actually goes straight out into the middle. Where the values are the same, but one of them's negative.
Okay, so let's go the other way.
You're given the point, you got to figure out the angle.
Root 3 over 2, 1/2.
30 degrees. Because that's the one where it's the long and then the short. So it's in the 30 degrees. This one, well, when they're the same, it's 45-degree family, but this tells me quadrant 2, doesn't it? So what's the angle of the 45-degree family in quadrant 2? 135.
How about this one? 1, 0.
No, that's 0, 1.
0
0
or 360.
or 360. Remember, when it's 0,
You also write 360 as well. That's the only one where you have to write 2. Negative 1/2, negative root 3 over 2.
so that's quadrant 3,
60.
60-degree family. So what's the measure in quadrant 3? 180 plus 60 degrees? 240 degrees. This one's quadrant 4. And it's the long and the short, which means 30-degree family. 330. This one, straight down. Okay.
The whole reason for this is, now that we are familiar with this, we can take it one step further and actually do trig ratios.
So in the next lesson, by the time we're finished, you guys are going to be able to find the sine, cos, and tan of all these angles
Without using a calculator. Okay?
So that's the unit circle.